Hello everyone, welcome back. And we are going to, this is part 2 of the video lecture for section 2.4 on linear models, linear modeling. So for this example, a person drives a car on a road trip. At the start of the trip, she fills up a 19.4 gallon tank with gas. During the trip, the car uses 0.05 gallons of gasoline per mile. Let G of x be the number of gallons of gas remaining in the tank after the car goes X miles. Okay. So once again, we're dealing with a linear function. G of x is a linear function, so G of x is going to be hopefully in the form of mx plus b. And so we want to find what is, first of all, the slope of G. And I think we kind of already sort of see that it was right. The answer is right here. It's 0.05 gallons of gasoline per mile. Now, the one thing you have to be careful is because G of x is the amount of G of x starts when x equals 0. It starts with 19.4, and then it just goes down. So G of x is actually decreasing, so the slope should be negative. So the slope is actually negative 0.05. Okay, and this would be gallons per mile. Right. And by the way, so you think, why isn't miles per gallon? Because of what G of x is defined. G of x is defined to be the number of gallons. So the rate would be the change in the number of gallons divided by the change in the number of miles. All right. So now we want to find the equation for G of x. Okay. So we can see that G of 0, initially we know that it's 19.4. So G of 0 equals 19.4. And then from there it's pretty easy. We know that G of x is going to be negative 0.05 x plus b. Plug in x equals 0. We get 19.4 equals 0 plus b. So b is 19.4. So G of x is going to be negative 0.05 times x plus 19.4. By the way, even if we weren't sure about this part, the answer for part A, it would be easy to pick two data points. You could check, for example, G of 0 is 19.4, and then you could figure out what G of 1 would be. That would be 19.4 minus 0.05. Okay, so you could do this, get 2 points, find the slope of the line through the point, find the equation of the line through the point. It would be the same way. All right. Well, the x-intercept. What is the x-intercept of G of x? So we want to find x is what when G of x is 0. Okay. Normally we would set y equals 0, solve for x, but in this case our y is going to be G of x. So we have negative 0.05 x plus 19.4. We set that equal to 0. And we can subtract 19.4 from both sides. So this will be negative 19.4. And we can divide everything by minus 0.05. Okay, make sure you have a minus here because we know x must be positive since x is the number of miles. So this is going to be, when you plug this into your calculator, this is going to be 388. Now what does this mean? Well, x represents the number of miles, so that means once you drive 388 miles, you're going to be out of gas. Okay, so miles. The tank is empty. All right. If the driver refuels when 1 gallon of gas remains, she should refuel after how many miles? Well, this is almost like what we're doing, we did last time, except that we want g of x to be equal to 1 rather than 0. So we're asking x equals what when g of x equals 1. So we can set, again, negative 0.05 x plus 19.4 equals 1. Once again, we can subtract 19.4 from both sides. So we have negative 0.05x equals negative 18.4, I think. And so x will be negative 18.4 over negative 0.05, which is 368. So it's 368 miles. What we would want. Okay, so once you have the equation, things are pretty straightforward. Okay, let's look at this last example. It's a little tricky. Says a telephone company charges $49.99 per month for local calling, and an additional 6 cents for each additional minute of long distance calling after 450 minutes. So if a person receives a bill of $65.99, how many minutes of long distance did he call during that month? Okay. So let's look at, just for a moment here. So the $49.99 is flat, and then we have each additional minute of long distance. Okay, so for every so it's going to be the additional minutes after 450, that times 6 cents. Okay, and then we add all that. So the cost would be $49.99 plus okay, so we're going to say it's x minus 450 times 0.06. Now we have to, this is important, what do we want x? Where x is the number of long distance minutes. Okay, it is very, very important that we define our variables here. Okay, so that's the bill. So in this now, one thing we should emphasize is that x is great. We're assuming that x is greater than or equal to 450. We can't use this equation if x is less than 450. If x is less than 450, then the cost is going to be $49.99. Okay. So we want to emphasize that. But here, okay, so what was the cost? Well, if the cost turned out to be $65.99, this is equal to $49.99 plus x minus 450 times 0.06. Okay, and then we just want to so we could solve for x, and what we'll do is so there's a number of ways we can do this. Let's first subtract $49.99 from both sides. Okay, if we do that, then we get 16 on this side, and this is x minus 450 times 0.06. Okay. Now we could just distribute this 0.06, but we don't need to, right? because we can just first of all divide 0.06 by both sides. Okay, and that'll tell us what x minus 450 is. So let's do that. Okay, so 16 divided by 0.06 on our calculator, this is 266.67. Okay, we can just round to 2 decimal places. And then this is x minus 450. Okay, so now we add 450 to both sides. Okay, so this turns out to be 716.67 equals x. All right, so we're talking approximately about 717 minutes. About. One thing here is, just one thing about this function is that this is actually a linear function. We could, if we wanted to, we could multiply this out. We could say this would be 49.99 times 0.06 times x minus another constant, and we could just add these two numbers together. And what we would get is this would be 0.06x plus something. Again, the problem with that is that only works if x is greater than or equal to 450. Okay, because of how this is set up. Okay, so that's all we have for you right now, and we'll see you next time.